Number 1, benchmark 1. To solve this absolute value, the first step is to get the absolute value by itself. So we do that by minusing the 7 over. So I now have 5x minus 2. The absolute value of 5x minus 2 equals 12. Okay, my question from here is, we want to make this equal to 12. We also want this to equal a negative 12 because the absolute value would change that negative 12 into a positive 12. So if we want what's inside of here to equal 12, well, we can just simply write it as, well, 5x minus 2 should equal 12. We also could write it as 5x minus 2 should also equal negative 12 because what's inside of here could be 12 or negative 12 because the absolute value makes both of them 12. So what we're going to do is we're going to solve both of these, and we're done. You got to remember absolute values almost always have two answers, so be careful about that. So we solve this one, we just add 2 over. We got 5x equals 14. We add 2 over. We got 5x equals negative 10. And then we're going to divide by 5. That gives us x equals, looks like 14 over 5. And here we divide by 5. And we got x equals negative 2. Those are your two answers. And we're done. If we plug in either of these to the original equation, they should come out true. Nothing else will be true. Those are the only two that would come out to be a true statement. Number 2. Very similar, except with number 2, you have other things to worry about because you're going to graph as well, because it's inequality. Now, with the inequality, you have a little trick. If you have a less than or equal to, less thans, I call it less than, and I put an and, less than. Less thans are less, or ands, less than. Greaters or greater than or equal to's are greater. Little way to remember it. You have less thans and greater. So this one is a less than. So this one's going to be an and. Meaning, you're going to make up two equations. Just like over here, you're going to make up two equations, but it's going to be an and. So your first equation is simply going to be 4 minus 2x is less than 6. And the other one is going to be 4 minus 2x. Switch the sign and change it to a negative 6. So the first one's exactly the same. The second one, the inside, you flip the sign and flip that sign. And now we're going to solve them. Solve each of these. So minus the 4 over. Looks like a 2. Minus the 4 over. Negative 2x is greater than negative 10. To solve this, we're going to divide both sides on this one by negative 2. So when you divide by negative, first of all, it's negative 1. But when you divide by negative, the sign actually flips. You have the word and. Divide this by negative 2. A negative divided by negative is a positive, and the sign flips. That is not the proper way to write the final answer. So the first thing is let's graph this. Then we're going to write the final answer as an and statement. So looking at this, x is greater than negative 1. So negative 1's our boundary. Greater than means this way. So we're going to the right of negative 1. And x is less than 5, so we start at 5, and we're going to go this way. And what you notice is you're going to be shading in between the two dots. Now, should I be filling in circles? No, because these are less thans and greater thans. If they had or equal to underneath these signs, you would be filling in the circle. But since they're just less than and greater than, it's open circles. So that's the graph. All ands are shaded between. And the way we finally write this is like this. That's how you write an AND statement. It's called a compound inequality. And what it basically kind of says is x is between -1 and 5. Another way of kind of seeing it is if I cover this up, x is less than 5, doesn't it match that? And if I cover this up, doesn't this match this? It's just as backwards. You flipped it around. This is x is greater than -1. This is x is greater than -1. So please remember to write ands this way. If it's an or, you just write or between. Or is cool. But ands have an extra step of how to write the answer.